Hello, this time I'm just going to do a couple of examples of solving equations where we have to use trig identities. And I've just picked these random, so I have no idea what they're going to use. They might be the same technique, they might be different things. I honestly don't know. We'll have a go, and hopefully you can see the process of thought that goes into it. If nothing else, then you can sort of try and replicate that. Okay, show that 5 sine squared theta plus 4 sine theta equals 0 can be written in the form of a sine theta times b cos theta plus c equals 0. Stating the values of a, b, and c. Okay, interesting. So I'm not sure where that's going to come into it, but we can certainly look at this 2 theta and think, well, that's going to be a double angle. So if we remember the double angle rules, is that sine of 2 theta is 2 sine theta cos theta. So if we substitute that in to what we've got here, we're going to end up with 5 lots of 2 so it's 10 sine theta cos theta plus 4 sine theta equals 0. And actually, this is fine now, because we can just do some factorizing, can't we? Because sine comes into both. That's all they've done. They've factorized it. So 10 and 4, we can bring out 2 sine theta, and we'll leave behind 5 cos theta plus 2, and that equals 0. So that's nice, and we've found the values of a, b, and c as 2, 5, and 2. Hence, solve for theta between 0 and 360, the equation this equals 0. Well, because they've factorized it like this is now quite nice, because we can just say, okay, it's a bit like when we solve quadratics and we end up with something like, x and x plus 2 equals 0. If this one is just 0, then it makes the whole thing 0. And if this bracket is 0, so if this x value is minus 2, so we can do that quite easily. We just have to say that 2 sine theta needs to equal 0. Well, of course, the 2 can just go. Okay, and so where between 0 and 360 will that be true? Well, notice we're not allowed to be 360. So theta can be 0 and 180, but we're not allowed the 360, where it would also equal 0. Looking at the sine graph like that, there's a 0 as well, but we're not allowed that one because of the strict inequality. And then also we can say here that cos of theta is going to equal minus 2/5, because we've got a coefficient here. We need this whole thing to equal 0, so cos theta has to equal minus 2/5. So theta is going to be cos the minus 1 of 2/5, and we may as well finish it up. I could leave it for you to do this bit, but we'll do it anyway. 2/5, and we get 66.42. Okay, that's because I missed out the minus sign. I did think that was a bit weird. Thought that was strange. So let's put the minus sign back in. Oh, too far. Minus sign. Right. Okay, that makes more sense. 113.57. Okay, I don't know if it says about the rounding, but let's treat it as 113.6. So theta equals 113.6. But of course, we need to work out the other value. So this is where we do our cast diagram, or all students talk crap, as I remember it. And if 113 is over here, it's in the negative cos. Well, that makes sense, because it gave us a negative value. The other one that's negative cos is this bit here. So if that angle is 113.6, well, we need this angle here. So we need to know what that difference is, and then add that onto 180. So if we do 180 minus that answer, we get 66, and then if we add 180 onto that, then the other answer should be 2464 with a decimal point in it. Degrees. Okay, so we've got 4 answers for this just by using the factorized as like we would as a quadratic, and then just doing the cast diagram in order to find the various values of theta. Okay, so let's have a look at the next example. And it's very similar. We've got to show that. We've got to show that this thing with a cos squared and a sine squared equals this thing. And it's tricky, these ones, because you've got to try and spot something. There's no double angle in here, so we need to sort of think what these bits are going to equal. But there is a double angle here, so there's definitely something to do with a double angle, but we're kind of doing it backwards. Now, officially, what you're supposed to do is take the thing that they've asked for and mangle it and turn it into this thing. That's quite tricky for this. I think it would require quite a bit of playing around. You'd think it would be quite straightforward because cos of 2x is cos squared x minus sine squared x. So it should be quite straightforward, but there's a 3 there. So I don't know if we can do anything about that. I'm tempted to sort of say, well, if we start on this side, we could show that this turns into this, and therefore, you know, we've done it, although it's just slightly unsavory. It's usually that, you know, you're supposed to start on this side and go that way, but it might be we'll have to. But let's just give it a go. We've got cos squared x and sine squared x, but the problem is I've got this 3 here. So I wonder if we're a bit cheeky, and if we split this into, this is just 3 cos x squared, so we could write this as 2 cos squared x plus another cos squared x, yeah, 2 of them plus 1 of them is 3, minus sine squared x. So we could do that, and then this thing, we can use this formula and turn into cos of 2x using the double angle. But what about this 2 cos squared? Well, actually, thinking about it, we can do that in cos of 2x as well, because doesn't cos of 2x, if you divide, let's have a think, we want it in there, if we divide everything, if we substitute in here, instead of this, it's minus 1 minus cos squared x, then we can end up with the formula 2 cos squared minus 1. And here we've got 2 cos squared. So we can rearrange this and say, well, 2 cos squared then equals, so let's add the 1 to the other side, cos of 2x plus 1. So it's using the double angle formula, but rearranging it for the cos squared that we want to get out. And now this is going to work really nicely. So this is cos of 2x, that's 2x plus 1 plus this, and we can just put those together and say it's 1 plus 2 lots of cos 2x, and we get that. Now, I appreciate the idea of splitting that apart in order to work on this bit isn't particularly clear. That comes from having done lots of examples and thinking, oh, well, you know, feels familiar to do this, or I wonder if there's a little trick here. And it happened to work because what was left was something that was rearrangeable in a similar way. If this had been left with something else that was grotty, then I might not have been able to do it. So you could potentially, if that's not so clear, it would have been easier, I would think, to start on this side and substitute in what cos of 2x is, and expand that bracket and then rearrange it, and then it's possibly easier to get it to sort of look like that. I'm not sure, but maybe you can have a go at doing it from the right hand side and see what you get. So now we know that that's true, we can say hence sketch for minus pi to pi the graph of y equals this thing. But we know that that is the same as this thing. So this is now just a transformations of graphs issue from minus pi to pi. So for cos, because yes, we're doing it for this thing, and this is built on cos, okay? Cos would look like this, like this, between minus pi and pi, because then it would come round and finish it off. So yeah, so minus pi and pi. But we now need to do our transformations, okay? So first of all, it's going to be twice as narrow. It's going to squash in, okay? So of course this is infinite. It carries on going. So actually, we're able to sneak in the whole picture of cos in here because that 2 has squashed it in. And then, so we know that that's pi over 2, so this is pi over 4, so we could label that minus pi over 4, of course, and this is minus 3 pi over 4, because it does say shown coordinates of points where the curve meets the axes. And here it will be pi over 4 and 3 pi over 4, but I won't clutter the diagram to write those in, but you would in an exam, of course. Okay, so then what happens? Well, then the 2 in front is going to stretch the whole thing up. So these points are going to stay still, but the graph is going to get twice as tall and twice as low. And I'm not actually going to draw that in because I can just squash the axes instead and say that this is going to go to 2 and this is going to go to minus 2. Of course, it doesn't intersect there, but just so we keep an idea of that. Okay, so that's doing quite nicely, and then it scuppers us because we get a plus 1. So it's going to move the entire thing up. Now again, glad I didn't bother writing those pi's in before then, because they're all going to go. Okay, so we can make this easier for ourselves to draw by shifting the axis down by 1. So if that's 0, then it's going to come through here. Okay, which means that these aren't the correct values anymore. That's been shifted up, so that's now 3, and that will be minus 1, although we don't need to plot that one. So what about these values then? What values are they going to be? Well, we should probably be able to work it out logically. If we hadn't... hang on, let's think about this. If we hadn't shifted it yet, then... something like this, then at this point, this was the value of minus 1, okay, and this is the value of minus 2, so this is halfway, and it's this value that's coming up to now be the new x value. And so if this is minus 1, it would normally be when cos would equal minus a half, but of course I made it twice as big, and cos equaling cos of x, of course I missed out the x, equaling a half is going to happen. We should know when those are. That's cos of 60 that equals a half, isn't it? So that would give, except it's minus, so being minus a half, so we need our cast diagram, that would be 60. All students talk crap, so it needs to be in the second and third quadrants, so it's going to be 120, and it's going to be 60 around here, so that's 240. So 120 and 240 are the x values for there, and of course the minus values, but that would be if we hadn't squished it in sideways, of course, but we've squished it into half the size because of the 2. Okay, so the plot thickens again. So instead of being 120 and 240, it's going to be 60 and 120. So that one's at 60, that's 120, and of course the minus values. But these are in degrees, and we're supposed to be in radians. It's just easier for me to think in degrees. So let's just do those conversions. So plus or minus 60 is going to be plus or minus pi over 3, and 120 is going to be plus or minus, so let's have a think about this, it's 90 minus, so it's going to be 2 pi over 3. So those are our 4 values for here, 1, 2, 3, 4, minus 2/3 pi, minus 1/3 pi, 1/3 pi, and 2/3 pi. Now, if you're struggling to follow that sort of process of logic in my head, then don't worry, there is another way to sort this out. We got the graph picture by transformations of graphs, and now we just need to have the value where this thing equals 0. So we could just solve it. 1 plus 2 cos of 2x equals 0. So we want cos of 2x to be, let's have a think, minus 1/2, which actually I got by logic, but there we are, could have done it much more easily this way, and then we can say that 2x equals, and then if you do your inverse cos, and you'll get your 2 different answers because of doing the all students talk crap, and then obviously you can then half those. You'll get 4 answers by... How will you get 4 answers? Because when you solve this, you're going to get these 2 answers here. And then we know just by the symmetry that these 2 will be the same. So you'll get the 2 positive values that will give this, the pi over 3 and the 2 pi over 3, once you've divided by 2, and then to get these ones you can just say, oh well, and then the minus values because of the symmetry. So you can do that if you find it easier just to solve it and get those values. That's fine, easy peasy, because we know it equals 0 on the axis. So is that everything we need to do? Showing the coordinates of the points where the curve meets the axis. Yes, I've got the 3 up here, and I've got 4 places it meets the x-axis. Once I've labelled them on, obviously you would do that. So hopefully you can see how I try and think about things. A lot of it is just give it a go, hope for the best, and if it starts to get more complicated, then possibly go back and try a different strategy. It's all about experience. So give them a go, ask for help when you're not sure, and hopefully build up a catalogue in your head of ways of dealing with things. Well, I've seen something like this before, or well, that looks very similar to the answer to one of these things. Can I muck about with it and make it fit? Anyway, I'll leave you there because it's turned into quite a long video again, and then you can put any comments down, any questions down in the comments below, and I'll say cheerio now.